Good afternoon. My name is John Waterhouse, and it is my great pleasure to welcome you here this afternoon as we talk about some of the exciting things that Congressman Larson touched on. We have a impetus to alter the way we've traditionally done things, to improve our environment. We have legislation underway that is creating a path for funding and money to come. We have new technologies that are coming out and are offering choices to the marine industry. And I think this is all extremely exciting as we look at the discussions today and think about where is this industry going over the next 30 years. And I say that with some perspective because I have been with Elliott Bay for over 30 years. I and two partners started the company in 1988. We have always focused on the commercial marine industry and offering services to our customers of marine engineering, naval architecture, transportation analysis, and production support services. As Elliott Bay, we have a wide range of experience. We're probably best known, of course, for our work in ferries and passenger vessels, as epitomized by the new Staten Island ferries that were, the third of which was just delivered this year. It's humbling to me that a Seattle-based firm can have such an impact on a major city like New York. That was a story that 30 years ago you wouldn't have heard. And so things are changing, and I think that's part of the message today is that change is something to embrace and to work with. When I was approached about being the leadoff speaker at this, my mind went in strange directions, as my wife will tell you it usually does. My first thought is, what is green? Well, Kermit the Frog is green, right? Running lights on vessels are green, or at least the starboard running light is. In classic English racing cars, are they green? Well, in color maybe, probably not in terms of pollution or environmental impact. And so I turned to the dictionary to say, what are definitions for green? And it's a color between blue and yellow, yes. It's not ripened or mature. I'm not sure that's the definition of green we want to use. Fresh and new, now that's beginning to resonate. And concerned with or supporting protection of the environment. That's really what green is here today in the context of what we'll be speaking about, is we're looking at ways to take this environment, this planet Earth that is our only place to live, and try and be good stewards of it, be better stewards of it, perhaps, with some of the new technologies that are available to us. Elliott Bay's been involved with green initiatives for a long time. I was going through the corporate archives and I realized back in the 1990s, we were working with one of our customers, Pierce County here in Washington, and they were actually interested in the use of compressed natural gas as a fuel for their ferry at the time. Since then, we've got involved with the development of the EPA standards for diesel engines. We have promoted the notion of a LEED type certification, and if you're not familiar with that, that's a building industry term for leadership and environmental design of buildings. So some way of being able to certify that your vessel that you're built and are operating meets environmental standards. And we started doing emission studies for a variety of operators as people were saying, well, I need to benchmark my emissions now so that as I make changes, I can see what is the degree of those changes, and I have a way of justifying to my board, my shareholders, whoever, that these investments are worthwhile. We also have gotten involved in cryogenic fuels. Originally looking at LNG as a transportation fuel, designing bunkering barges for various customers on that. Design of a towboat that could be using LNG as a fuel for like a fleeting operation where the vessel operates from a fixed base, could carry a relatively small amount of LNG and be able to service its customers. More recently, we've been looking at hydrogen, and we were participated with Sandia National Laboratories in looking at the feasibility of hydrogen-powered ferries for the San Francisco Bay Area. So our learning curve on these new fuels, on things like how do you handle hydrogen, what are the safety concerns, what are the material properties, have helped inform us as we have discussions with our customers. More recently, LAB has been involved in looking at energy storage systems, because one of the messages that has come out is the focus of industry is on energy at the end of the day. What kind of energy do you need? How can you save energy? How can you store energy for using it when you need it? So looking at battery propulsion for, again, a number of ferry projects, beginning with the Jumbo Mark II, which is the largest ferry largest class of ferry operated by Washington State Ferries, on down to more recent projects where right now we have beginning construction, a all-electric ferry for Casco Bay, Maine, an all-electric ferry for, what's the other one we've got? We've designed an all-electric ferry for Governor's Island. That's the other one that's starting construction. We have one that will be out for bid shortly for Louisiana DOTD on a new electric ferry. So energy storage has become part of the lexicon, but not all routes, not all operations are suitable for running all electric. So that's why we need to look at what's the future going to bring. So there is no single solution to replace what has been a 120-year technology, an internal combustion engine burning fossil fuels. That's a remarkably, if you look at the history of technology, that's been a remarkably robust technology. But as it is being supplanted, there is no single solution to replace it. We're also seeing that climate change is going to increase pressure on the marine industry to go green. I was talking to a ferry operator, and he says in every public meeting, someone comes up to him and asks, what are you doing on improving the environmental footprint of your ferries? So the public, the customers, and the passenger vessel side are asking the questions. We also know that on the freight side, the transportation side, they too are asking the questions of what can you do to be more environmentally responsible? Another thing that is true is that new technologies bring new risks that impact regulations and industry acceptance. If you had asked me in 2013, would Washington State Ferries be operating an LNG-powered ferry, I would have said absolutely. They were meeting with Coast Guard on it. They had a package out on the street on industry to convert a class of ferries to LNG-powered, but that didn't happen. Why didn't it happen? In part because of the risk discussion. Who absorbs what risk? Does the state absorb risk? Does the private shipbuilder absorb risk? Does the vendor network absorb risk? So as we look at these new technologies, let's not be afraid to have those discussions about risks and how are they to be handled and shared. For some closing thoughts, this is really an exciting time as an engineer because the pace of innovation is forcing us to stay educated. You can't just go hide in the corner and not be exposed to all this new exciting things that are happening. A piece of advice is to use external resources as pilotage to help you find your path forward as an operator, as an owner, as a regulator, to look at what are those risks, how are they defined, and what do we do about them. A friend asked me once, what's the difference between a map and a chart? And I thought about it, and I said, well, I don't know. What is the difference between a map and a chart? He says, well, a map shows you where you can go. A chart shows you where you shouldn't go. And so as we proceed forward down this technology path, we will need both maps and charts. And then finally, find the solution that suits your operation, because every operation is different. So just because you read a wonderful piece in Marine Log about this new technology, do your research, take a look at it. Maybe it makes sense for you, but also beware that we're talking about there's not a simple canned solution that will serve all customers. So ask questions, Be excited, and I hope you enjoy today's program. Thank you.
My name is Lydia Benger. I am the Technical Director at Elliott Bay Design Group. In other words, I support every member of our engineering and design team. I've been in the marine industry for approximately 13 years, 10 of which have been with Elliott Bay. The key takeaway I want you to get from this slide is I am an extroverted introvert, and I really look forward to talking to you one-on-one when this presentation is over. So, alternative propulsion. It's a shift from traditional fossil fuels. We've been doing it for a long time. We're all familiar with these pictures on the screen. We've got an all-electric car, a plug-in hybrid, a natural gas-powered semi-truck. Others you might be familiar with: hydrogen fuel cell trucks, biodiesel in your standard diesel car, hydrogen fuel cell trains just started in Europe. I even found a 1982 study from the US Department of Transportation, which was investigating alternative bus propulsion, which considered electric, hybrid electric, and methanol alternatives. So what does that mean for the marine industry? We've got options. We can consider biodiesel, typically a direct replacement in existing diesel engines. Several operators we work with already consider adding some percentage of biodiesel to their operation. Natural gas. Engine manufacturers have produced dual fuel engines for some time. These engines typically require a diesel pilot fuel, and natural gas is still a fossil fuel. Storage of liquid and compressed natural gas is complex. Ammonia has an extensive history as a refrigerant in the fishing vessels, can be burned in a spark ignition engine. It's a zero carbon fuel, but how is it produced? Methanol. Methanol can also be burned in internal combustion engines, can also play a critical role in hydrogen propulsion, but more on that later. There are promising diesel alternatives to reduce our carbon dependency, but they are in development and they will require some maturation. This image here is from a DNV study, which was examining a variety of future fuels, what is most likely to move us forward in decarbonization. On the left-hand side, the x-axis is time from current to future, and each of the color blocks represents a transition from traditional fuels towards ammonia. On the right side, again, from current to future time, a transition from traditional fuels towards methanol. In either case, the volume of vessels operating on a monofuel internal combustion fossil fuel reduces, and over time, we increase our use of alternative fuel. So where does Elliott Bay come in? Hybrid electric and alternative propulsion vessels are making the headlines. All electric vessels are common, and increasingly my clients are asking me about batteries. I have clients asking about the possibility of an all-electric operation, and as the theme today suggests, what are their options beyond batteries? And my answer is always, let's discuss your operation. Thus, one of my main tasks, the propulsion feasibility or selection study. Elliott Bay Design Group has been doing these studies in some form for the life of our company. Perhaps previously we were evaluating medium speed versus high speed engines, tier 3 versus tier 4 engines, quantity of engines, or type of propulsor. Alternative fuels are just an evolution of a well-worn path. Initially, we'll identify 3 or 4 different propulsion options that you might want to consider for your operation, and together to understand the key motivators that will drive your selection. Each vessel, each operating scenario is unique. We need to identify the route profile, the shoreside infrastructure, capital costs, operating costs, emissions, and regulatory mandates. They may impact your choice. Generally, we can expect that these new technologies are going to cost more than your standard diesel mechanical propulsion. So let's dive into that first very important piece, the vessel operation. We need to understand from the operator, are there specific arrangement requirements? For your geometry, do you carry vehicles? Do you carry passengers only? Is it double-ended? Is it single-ended? Are there shallow water, deep water? All of those things will play a part in selecting your propulsion system. What are your speed and power requirements? Are we replacing an existing vessel? Is the power demand for each portion of the route already determined? Or do we need to determine those powering requirements based on a new vessel design? What are your operational requirements? Are there strict refueling or battery charging windows? Is the vessel in constant back and forth motion, or is there downtime? This picture here is an example of a sample power profile, which I borrowed from a recent propulsion feasibility study. In this case, one of our talented engineers evaluated 5 years of engine data extracted directly from the engines to determine the average one-way transit. From that study, we are assuming a new vessel would be constructed in the same size and arrangement as the existing vessel. Beyond your vessel operation, I think the next most important thing is the shoreside infrastructure. If we're pursuing electric hybrid or an electric vessel design, do you have adequate shore power? Is there adequate terminal space to accommodate any charging apparatus? What kind of rate structure will the local utility apply? Is that negotiable? Is one end of the route an island? Is there adequate submarine cable to supply power to that island? Or are we looking at only charging on one side? Alternatively, is alternate fuel an option? Biodiesel, methanol, and ammonia are increasingly available near marine ports. So we're looking at the last mile delivery, and many of these fuels are truckable. Shown here is a map of the United States with methanol, ammonia, and LNG sources identified. And then the next picture there is the charging apparatus of an all-electric ferry. You'll see that there's 2 arms that come out, one to hold the vessel in place, and one to charge the batteries. In this case, the vessel has ample space at the terminal along the side of the boat, which is not the case for many of our operators. I don't think I need to explain capital costs, operating costs, and emissions to everyone here, so we're gonna just glaze on past that. So let's talk about outcomes. There's many outcomes that you could have from one of these studies, and we will look for what fits best with your requirements. Possible outcomes may include a diesel mechanical, a traditional diesel engine driven shaft, which would include ship service generators for hotel power. Sometimes that is the greenest option. Diesel electric with onboard diesel generators that provide all of the power for propulsion and hotel power. Diesel electric hybrid. This is a play on the diesel electric with battery storage. All electric, where shore power infrastructure is used to meet the propulsion and hotel needs. Hydrogen fuel cells, utilizing compressed hydrogen stored on board to supply 2 fuel cells, which then provide electricity to your propulsion and hotel needs. Methanol and hydrogen fuel cells, also more on that later, with methanol reformers supplying hydrogen to fuel cells provide electricity drives your boat. Methanol or ammonia internal combustion. We've had conversations with many engine vendors that are currently researching the use of ammonia and methanol injected directly into traditional internal combustion engines. Touching just a little bit on what Elliott Bay's experience is beyond what John already addressed. We were active with the Washington State Ferries Olympic class hybrid study. We developed the feasibility for the hybrid conversion of the Olympic class ferries and supported the functional design effort. The Whatcom County Department of Public Works, as a subconsultant to KPFF Consulting Engineers, we developed a high-level comparison of 3 replacement vessel alternatives to support the Lummi Island Ferry level of service analysis. We analyzed effects of vessel alternatives on sailing schedule, passenger capacity, crew requirements, and estimated construction and operating costs for each alternative. And as you heard at the beginning of today, they've just received funding to move forward with that. The Trust for Governor's Island, as a hybrid electric ferry for carrying passengers and vehicles, it will have the battery capacity to run all electric when the shoreside power is installed. And Casco Bay Lines, also a vehicle passenger ferry with the battery complement for all electric. And of course, the hydrogen one. This is our latest involvement in alternative propulsion, as you likely know. I've been developing the mechanical systems for this project, working with the hydrogen piping, methanol piping, HVAC, cooling, you name it. So we are actively cutting our teeth on how to compile this system together. This vessel will be IMO 2030 and Subchapter M compliant. It'll have 550-mile range between refueling. The propulsion system will be scalable from 1,700 horsepower to 3,500 horsepower. We'll be able to refuel safely and conveniently, similar to that as diesel. Enhanced propulsion system redundancy. It'll have a 12-hour zero-emission standby, and no shore power connection is required. You're going to see this image a lot today, as you noticed in the flashback through the slides. But let me just give you a quick breakdown of how the propulsion system works. Basically, we have deionized water and methanol in the tanks in the hold. These are mixed together to a specific weight ratio and supplied to the methanol reformers up top, the green box. The reformers output hydrogen, which is supplied to the fuel cells, the blue box. We've got a buffer tank there in the middle. We actually have 4 buffer tanks, but the fuel cells produce electricity, which is then supplied for propulsion and auxiliary loads and storage in batteries. And you can see all the partners here on the slide that are working with us to complete this design. I'm also showing you this cutaway for simplicity. It's compact, and it's easy to identify the different moving pieces. But we can apply that to a double-ended ferry. Again, you see methanol and deionized water tanks in the hold, reformers up top, fuel cells up top, batteries back down in the hold and supplying energy to propulsors and hotel loads, and of course, a single-ended ferry. You also have these cut sheets on your table, so take those with you. Some conclusions and takeaways from today. For my presentation specifically, there is no one-size-fits-all design. We need to look specifically at your operation and determine what your future looks like. There's plenty of technology available now, and it is constantly changing, and Elliott Bay is here to help you walk through that path. And expect that it's going to cost more. You're not going to get it for the same price as a diesel mechanical ferry. Thanks again. My name is Lydia. I look forward to one-on-one conversations with you afterwards.